Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad Afi Amin bin Wan Muhammad Suhaimi. This is a video presentation for industrial project MEM560. The title of our project is Ball Bearing Set. The members are Nur Dahiyah Shafia, Saidi Abdul Muhsid, Nur Fariza Aisha, and Nur Amalin Shahmina. Moving on to the introduction. The company that we have chosen is NTN Bearing Corporation. It is founded in 1918 by Noboru Niwa and Jiro Nishizono. It specializes in manufacturing ball bearings, spherical, tapered, cylindrical, and needle roller bearings. In 1980s, the company's catalog of tapered and cylindrical roller bearings were produced. In 1990s, the company released automotive clutch release bearings and specialty in agricultural bearing assemblies. In 2008, the company invested to SNR, which is a French bearing company. As of today, the NTN operates more than 50 plants worldwide, and it is the third largest bearing manufacturer in the world. Moving on to the design concept, the radius of curvature across the pathway of an inner ring is held between 51 until 52%. The radius curvature across the pathway of the outer ring is held between 53 until 54%. The pathway radius of curvature approaches 50% of the ball diameter as the stress between the ball and pathway decreases. It also moves the contact of the ball higher up to the pathway wall and producing more friction as the balls revolve around the bearing. As for the outer rings present as a concave surface to the balls. It lowers the contact stress. And inner rings, which in rotational plane present a convex surface to the balls, raising the stress. The raised surface on each side of the pathway is called the shoulder. The shoulder height is held to 22 until 30% of the ball diameter for inner rings and 18 until 22% for outer rings. The minimum wall thickness at the bottom of the pathway of the inner and outer rings must be thick enough to simultaneously support compressive stresses from the balls on the inside and hoop stresses from press fit assembly on the outside. Moving on to the product produced by the NTN Corporation, the first one is the BCA bearings, the second one is Bauer heavy duty bearings, and the last one is NTN SNR. So I will pass to Fariza to present the manufacturing processes and quality assurance.
Okay, next we move to the manufacturing process. So the first part is the races, which is we have inner and outer races for the bearing. So the races is going through the rough cutting. We use a lathe machine to cut the basic shape of the race, which will in a ring shape, and then a heat treatment. So the rough race then heated at the 1550 Fahrenheit, and then cool it by using oil to make them super hardened and brittle. Added with a metal tempering process, which is the race is heated at the 300 Fahrenheit and let them cool in surrounding air, which is a natural cooling, so that the races will be more brittle. Next is the ball bearings manufacture. So ball bearings is a ball that will control the bearings cycle. So the first process is the cold heading. So cold heading is when a thick metal wire is fed from a roll in a machine that cuts off it into a short pieces, and then the short pieces later will be smashed towards the middle to form a sphere shape, but there will be a flash existed in the middle of the sphere. So the flash later will be trimmed at the flash trimming process. So the ball repeatedly go in and out from a stationary grinding wheel with by a conveyor. So the stationary grinding machine has a groove a flat groove that will trim the flash until the ball is smooth. The process will be repeatedly until it will completely smooth. So then the ball will be undergoes a heat trimming. Heat trimming is a similar process as the race heat treatment, since we use the material used is the same. So then the finishing process of the ball bearing is lapping process. So by the lapping machine, the ball is lapped for 8 to 10 hours. The machine use grinding wheels instead of the grinder, a rough grinder, to cut down the ball into the actual ball size, depend on how precise a bearing they made. So the lapping also considered as the finishing process for the ball manufacturing. Next is the cages. So the cages of this bearing will be undergo a stamping and the bending process. So stamping is by cutting a thin sheet metal into a row cage shape and size, which will be cut into a ring, and there will be a circle for the ball to fix in the cage. So then after stamping will be bending process, which is the row cage is then bent into in a die to form its final desired shape. Depends on the ball. So the last part of the manufacturing process is bearing assembling process. So lastly, race ball and cages are assembled together and it's ready to coated with a rust preventative before the bearing is out to the market. Quality assurance or quality check process take place in order to prevent product from a defect. So next, I will explain about the quality assurance. So we have 4 main quality assurance here. So the first thing is a ring and ball inspection. So ring and ball inspection is a ring and ball going through automatic machine that use sensor to detect the size of ring diameter and ball smooth sphere. So unwanted size will be kicked out from this process. So next is the cutting and grinding tools inspections. By checking the cutting tools of lead machine, groove of the lapping machine, and then the die on the stamping machine to make sure the tools still can be used and have no error or defects. Lastly, the third one is the machine setup. So this QA process or quality assurance process is the same as checking tools, but the QA or the worker check the machine code or detections such as M code, C code, F code, D code. So the code that send detection to the machine before it start operate. So in order to avoid error and missing code, machine setup will be done quiet like a monthly or weekly, depend on the factory. So the last part of the quality assurance is assembly inspections or complete bearing inspections, which is we have formed a product of the bearing. So the bearing will undergo 3 different inspections, which is noise vibration test to make sure the ball bearing operate quietly, and then automatic scale to get rid of the bearing that has no required weight, which is unwanted weight and dimension. The last is laser marking. This quality assurance is to make sure or to ensure users or buyers easily select their desired brands and size of the bearing to be used later. So thank you.
Next, we will talk about problems that we face during manufacturing process, such as possible effects and other problems that we face. In rough cutting, the possible defects include rough surface, which are scratch marks and burn marks, which is caused by incorrect cutting parameters such as high feed rate, high spindle speed, and large depth of cut. Poor cutting precision is caused by dull cutting tool, while alteration of plant cut happens when the workpiece is not clamped properly in the fixture. In heat treatment process, the possible defects includes overheating, which is caused by heating for longer periods at high temperature. Burning grain boundaries happen when heating for a long period of time in oxidizing atmosphere very close to melting point. Oxidation, which are thick layer of scales on the surface of the workpiece, is caused by oxidizing atmosphere in the heating furnace. For grinding and lapping, the defects include grinding cracks, which are caused by the heat produced by the grinding wheels. If the grinding wheel wears out too soon, that is because the grinding wheel has lower relative hardness compared to the workpiece. Lastly, chatter marks happen when grinding wheel is not balanced. In cold heading process, the defects include cold shut, which is caused by improper design of the forging die. Scale pits happen due to improper cleaning of the forged surface. Die shift happens when the upper and lower die are not aligned with each other. Lastly, in sheet metal forming process, which include cutting, bending, and etc., the defects include uneven surface appearance, which is caused by unqualified stamping die. Deformation happens due to two reasons. Firstly, improper handling, and secondly, the elasticity of the sheet metal itself. Cracking happens due to overstretching or stress concentration. Now, we will talk about other problems. First is lubrication failure, which is caused by insufficient lubrication. Next, contamination is caused by foreign substance, such as dirt and abrasive grit. Improper mounting happens when the bearings are not mounted properly on rotating ring. Misalignment occurs due to improper installation, while false brinelling is caused by rapid movement of the balls in raceway when the equipment is idle, making the lubrication to wears away and the bearings cannot rotate anymore. Corrosion happens due to moisture, acid, low quality grease, and condensation from extreme temperature reversals. Fluting or electrical damage happens due to constant passage of alternating or direct current. Spoiling or fatigue is the result of overloading, excessive preload, and using barriers longer than its calculated life. Overheating is the result of excessive operating temperature and insufficient lubrication. Lastly, excessive load occurs due to too much load applied on the bearings. Thank you. That's all from me.
Some suggestion of suitable manufacturing process that can extend the life of the bearing, however it is significantly higher in cost. First of all is by using plastic cage. This is under the process called injection molding, where metal mold will be filled with melted plastic and let to be hardened. After it is hardened, we can assemble it. Second is by forging. Forging gives the raised material a fiber orientation that can make it less responsive to differences in steel grade. Third is by compressive residual stress, where it reduces maximum shearing stress and increase fatigue life. Fourth is by control hardness bearings that have hardness match rolling elements and races. There are ways to overcome problems in manufacturing process of bearing. First of all is to use the proper amount and also appropriate type of lubricant to avoid lubricant failure. Second, to reduce the risk of contamination, we have to filter the lubricant and also clean work areas, tools, fixtures, and also our hand. Third is by following proper mounting instruction, and also provide trainings to the employees so that they know how to properly install mounting. For misalignment, we have to inspect shafts and housing for run out of shoulders and bearing sets and use precision grade lock nuts. For fast brinelling, we have to eliminate or absorb external vibration that could cause the ball. Divert corrosive fluids away from bearings area can help with corrosion problems. Fluting or electrical damage can be avoided by preventing electrical currents from flowing through the bearing by grounding or using insulated bearings. Spelling or fatigue are best avoided by replacing the bearings or consider a redesign that uses a bearing with a greater calculated fatigue life, internal clearances, and proper shaft. For overheating, to mitigate the overheating, we can use thermal or overload controls, adequate heat pass, and supplemental cooling are among the best option. Reduce the load or consider a redesign using a bearing with greater capacity can help with excessive loads. There are some other products that can be produced using the same method as of manufacturing bearings, which is plumbing block bearing units and also slide bearings. They use the same methods, however, with different components.
Assalamualaikum, my name is Saidi. I will present my part, which is continuous quality improvement. There are a few things that we can focus on, which is the first one is the prevent machine failure. Machine failure can be prevented by establish a maintenance schedule. Organizations should be sure to establish a consistent schedule to follow for preventive maintenance. Next is eliminate potential defects. Organizations should seek to eliminate any potential machinery defects which could lead to failure. By looking into past failure of the same machine experience by other users or any notice from the manufacturer, individual can prevent these defects from affecting their business. The last one is utilize equipment monitoring. One of the best way to prevent equipment failure is to deploy a condition monitoring system. This technology includes sensors to measure key components and provide opportunities to perform preventive maintenance before larger issues arise. The second one is employee productivity. First step for employee productivity is use a team mindset. Quality won't be sustainably improved by individuals. To really make lasting and meaningful change in manufacturing process, it will take a team-based approach by involving multiple disciplines in the search for improved quality. A variety of perspective is obtained. Next is training and development. The ideal training program should consist of an approved documented program. This hands-on approach should include describing the job, show them how to do the job, and then letting them to do the job to validate their training. The third one is solve problem completely. All too often, manufacturing quality improvement fix the symptom of failure rather than the root cause. This can be done by adding quality inspection steps or rework station that make it more efficient to fix defects. Instead, a true understanding of root cause should be developed within the teams. When teams develop the ability to ascertain root cause of defects in the manufacturing processes, true solution to problems will be created that will not allow the return of the issue. The last one is employ strong process discipline. Throughout the quality improvement process, it is essential that strong process discipline is employed. Depending on the product that is being manufactured, deviation without proper team cooperation and anticipation of the change could have dire quality repercussions. One of the most common findings in third-party audit for organizations is procedures and instructions not written or updated. Some organizations rely too much on verbal communication and partially retain memories. The extent of documentation should be determined based on the complexity and interaction of the various processes as well as the scope of training for the employee. This is the distribution of work for our group. I think that's conclude our presentation for today. Thank you.